Yes, so the lesson was looking at exponential growth. In this particular lesson, it was looking backwards. So we were doing dividing exponents, and the rule is just take the exponents and subtract them. So what we want to do is to put that in a context. First of all, building a rule, right? So you saw in the very first part of the lesson was like, let's just expand 5 to the 7th divided by 5 to the 3rd. How many 5s are left? And then afterwards, it went really quickly to a complicated real-world problem. Here's exponential growth or population, and it's going to be this weird fraction, but the same thing holds true. So that's what was happening, really rules of exponents. These are all ships that are being broken apart. And so it's really a fascinating place. And here's the other thing. Chittagong is one of the fastest growing cities in the world. It's doubled in size. Well, I don't want to take away all the excitement. So let's read the investigation. Right. When I wrote this lesson, I was looking for a place that had an interesting story. Really I think actually it's probably anything. It came out in the discussion, I think. When the population grows so dramatically, things happen. And so this is Chittagong. This is a pretty interesting thing. Let's do the population of Chittagong then. So in in 2007, that was a few years ago now, the population of Chittagong is this. 3.5 times 1 plus 0.044 to the 7th power. What does that statement mean? Can you tell me what that statement means?
Just a new base population.
Okay, base population.
Yeah,
What do we call that? It's the starting value.
Yeah. So.
And why is it different between the two? Madeline, you have some
Because it started from a later year. In the first one, they had it start from 2000, but in this one, it starts from 2010.
Okay.
And so that's why.
Okay. So what does the exponent for the 11 mean, Helen? Okay, so when she's saying any number to the 0th power is 1. So this is 2010's population, 5.2 million. 2011, Justin, you would have to put that to the first power. Like if you have these classes of functions that we talked about, and one is this exponential class of functions. So there's exponential growth, and then there's these fractals that get smaller and smaller and smaller, and you can talk about a few things that happen there. When looking at geometry and polygons, there's all these tessellations, and then there are a lot of different contexts in the world for that. And then linear growth is really easy in so many ways, and then you can take that topic. So so these guys go to the movies every Friday. They have a big group of kids that go if they can, and so I'll say, okay, we start with that. So you're going to the movie, and it costs $4 for gas, and then it's $5 a person. How much will the movie be if 20 people go? How much will it be if 5 people go? And if no one goes, it's still $4 for gas. So, but then you can take that and you go, okay, so what does an outing look like in another country, and how does that happen? And I want the kids to see that math comes from within, or some people describe it as a cloud of knowledge, and they grab from that cloud. I'm not going to give them the answers if I can help it. So I think from the beginning of the year, we spend the first 2 or 3 months building this idea. It's a really tough beginning of the year for that purpose or reason. And then they start to move into this. They're taking charge, and they sometimes say, "Don't say anything to us. We got it." And so, but the engagement, you heard the conversations that were going on, and I think the level of engagement is just a little higher, especially if it's a really interesting story and it has multiple perspectives, and this one in particular does. So I think that's the case. And again, they have an emotional connection to this lesson in several different ways. And so when the mathematics slips a little bit, they have something to draw.